So you can see that we have found the angle, but because of its placement and what we know about sine and our unit circle and how it outputs, we're actually going to be using the obtuse side of it. You can see that these are supplementary, so that's how they are related as well. Now that I have two sides of the triangle, I know that the total is going to be 180 minus 35 minus 130.1. So when I do the subtraction, it gives me 14.9. So here would be my 14.9. So now we can see that we have found all the angles of this function. We now just need to finish it out by finding the missing side. Down here across from gamma, we're going to call that C. And so again, I'm going to use the sine of 35 degrees over 6 equal to sine of, we now know this angle, 14.9 over side C. So we can take this and solve it out. So I'm going to cross multiply. So this gives me 6 sine of 14.9 equal to C sine of 35. Solve this for C, so I'm going to divide by sine of 35. And so using your calculator, again, make sure you're in degrees. This is 14.9 degrees, 35 degrees. Do 6 times sine of 14.9, enter. Divide it by sine of 35, enter. And this gives us a C value of 2.7. So look back at your triangle. See if your answers make sense for your triangle. You'll notice that 14.9 is the smallest angle. Therefore, 2.7 should be the smallest side. 130.1 is the largest angle. Therefore, this should be the largest side. Now, if you consider the triangle that it would create, if we consider if how we got this 49.5. So this one would be 35. We have 8. If we drop this one down to give us 6, we know that this angle over here is also 49.9. So you can actually continue solving to give you 95.1 and then use your law of sines and you'll get this side to be 10.4. So again, even that triangle makes sense, that I can see that across from my largest angle is my largest side. Across from my smallest angle is my smallest side. So this case in point proves how you can get the different triangles like we saw in part 2, the possible outcomes of side-side angle triangles. And so you're going to have to use the criteria, what is given, what is the picture, to figure out, did I really need this 49.9 or did I need the 130 based off the picture that they gave me? And so for our case, this would have been the correct triangle, but you can see how it does form two triangles that are solvable. And the next one we're going to look at, it says solve for the unknown sides and angles of a side-side angle triangle. Solve for the unknown side and angles and round your answers to the nearest tenth. So when we're working with this one, let's first begin and look at what do we know about this triangle. You can see that we know that we have a side of 12, a side of 9, and an angle of 85. So this is similar to the one we just did. And so the first thing that I'm going to do is I notice that I have a relationship here between this angle of 85 and this angle of 12 and this side of 12. So I'm going to say sine of 85 degrees over side of 12. I also know this side here, so that's where I'm going to start. I'm going to say, okay, well, this would be angle beta. So I'm going to say sine of beta over 9 so that I can now cross multiply and solve this out. So this gives me 9 sine of 85 degrees equal to 12 sine beta. Divide both sides by 12. So I get sine beta to be equal to 9 sine of 85 divided by 12. And so that gives me 0.747. So then beta would be equal to arc sine of 0.747. And again, maintain these answers in your calculator. Do 9 times sine of 85, make sure you're in degrees, enter. Divide it by 12, enter. This is about the answer you get. Maintain that in there. Do arc sine of second and then do your answer button so that it gives you an exact value of 48.3 for beta. Now when I go in this, let's notice this. I'm going to do 180 minus the 85 minus the 48.3, and this gives me alpha to be 46.7. And you might be thinking, teacher, up here, when we did that arc sine, we didn't use the 49.9, we used the supplementary angle to it. Well, in this case, if I were to take beta 48.3 and I subtracted it from 180, I would get a value of 130.7. I already know that one angle is 85, so 130 plus the 85 exceeds my total of 180 degrees, so I know that it's not going to be the case of the previous example where I have two possible angles or two possible triangles. And so, again, follow the information that you know. In this case, we did not want to use the supplement because it gave us a very large obtuse angle. And so I'm going to take 180 minus the 2 that I know, and so I can get this third one, which is 46.7. So I now have all three angles. I have 2 of the sides. I'll just set up my sine ratio again and say, okay, sine of 85 over 12 is equal to sine of 46.7. I want to use this angle alpha to get side A over A. And in solving this out, you should get A to be 8.8. And so I really wanted to do this example here because I wanted to show you how it can be very similar to the previous example, but yet when you follow what you know about triangles, you end up just using that smaller value. So I want to kind of do one where it formed one triangle and one it formed 2 triangles. So moving forward, we've got one more example to look at here. It says find all possible triangles if one side has a length of 4, opposite an angle of 50, and a second side has length 10. So for us, what we need to do is we need to draw this out. So I'm just going to draw a very basic triangle here. I'm going to label it A, B, and C. So this would be alpha, beta, and gamma. I just like to kind of draw it based off that so I can figure out what I'm working with here. So it says that if one side has length 4, so let's call A to be 4, opposite an angle of 50, so 50 degrees needs to be alpha opposite that side, and a second side has length 10, and so let's call B to be 10. So you can see I still have side-side angle going on in this problem. Now it's irrelevant whether I put the 10 on the B or the 10 on the C, but 50 does have to be opposite the 4. So working with what I know this ratio here, so I'm going to say sine of 50 degrees over 4 is equal to, and we're going to use beta because it's also what we call B, so sine of beta over 10. I'm going to cross multiply, so this gives me 10 sine of 50 degrees equal to 4 sine beta, divide by 4. Using your calculator in degrees, going slow to compute all this out, and this gives me sine beta to be equal to 1.915. Now, if you remember how to work with sine, we know that this is sine of some angle that gives us a value. And remember your sine function? It looks something like this. So sine of an angle, so we're trying to figure out that angle, is 1.915. But remember with this function, the highest it goes is 1, the lowest it goes is -1. This is not in the range of sine. There's no way that this is going to work out because, again, sine of theta is equal to y, and y is between -1 and 1. So for this one, find all possible triangles, not possible. So just begin to work with problems that you know, but use the information that you have from previous section. We can't avoid all that. Now in part 3 here, it says finding the area of an oblique triangle. So we've been working with law of sines. Now let's begin to talk about, okay, if we find all the angles and sides, what about if we wanted to find area? So if you remember back to when we were working with just area with triangles, just in any given math class you've worked with it, you typically do 1/2 base times height. That's what we know. Well, what if we don't know a height? These were oblique triangles. If it had been a right angle, we would have a height. But these oblique ones, we're going to have to find the altitude or the height. Surely there's another way to do this. And so what they're saying is, if you're considered whether it's in between here, so you can see if the height is dropped within or if we have to drop the altitude on the outside of it. Either way, what we're going to do is we are going to use some of our sine ratios to kind of help perceive this. And so what they've done is they've applied the fact of sine is equal to opposite over hypotenuse and then manipulated this in order to get an area equation. And so you do 1/2 your base, so your base is b in either case, times your height, and they do it based off the sine ratio, or using, sine is equal to opposite over hypotenuse, and then we kind of get an area formula out here. And it's better written on this next page here at the very top. It says area of an oblique triangle. The formula for the area of an oblique triangle is given by, and I want you to notice they've written all three of them in terms of alpha, beta, gamma, and it's irrelevant which one I'm working with, but I want you to know the similarities. Notice if I'm using alpha, little a wasn't in here. If I'm using beta, little b isn't in here. If I'm using gamma, little c is not in here. So if you have two sides and an angle not opposite, that's how you're going to be able to create your area. And so let's kind of play with this. And it says this is equivalent to 1/2 the product of two sides and the sine of their included angle. So it's the angle between the two. So let's kind of figure out what's going on here. Now you'll notice with this example here, there is no triangle. So I might need to draw out what's happening to make sure I'm using the correct information. So I'm just going to draw A, B, C, alpha, beta, gamma. And so let's see, A is equal to 90, B is equal to 52, and the angle gamma is 102 degrees. So we do need to still be in degrees in our calculator. It says round the area to the nearest integer. Okay, so when you're working with this, it's going to be 1/2. You're going to do the two sides, sine of the angle contained in between. So I'm going to do 90 times 52 times the angle contained in between, so sine of 102. Now you can imagine if they had only given me other information, I might need to use previous problems, how we were finding all the missing sides, all the missing angles in order to get what I want. But this one I already have side angle sine, so I can work it out. So you want to go in your calculator and you would enter 0.5, 90, and I would use parentheses just like this, 52. I would enter sine of 102, make sure you're in degrees, and this is equivalent to, it says round to the nearest integer, and you should get about 22.89. Hopefully you have your calculator that you'll be using on your exam out while we're working through our notes and our problems so you can make sure your calculator is also giving you the same answer as what I'm getting. So you can see that the area formula is really nice. Make sure you are working with a side angle sine as you input it, and make sure your calculator is in degrees. So moving forward, let's look at some application problems. Everyone loves a good airplane, ladder, etc. problem. It says find the altitude of the aircraft in the problem introduced at the beginning of this section shown in your book. Round the altitude to the nearest 1/10 of a mile. So our goal is to find this side right here. So the first thing I'm going to do is I'm going to find a missing angle. I know two angles of this large triangle. So the first step I'm going to do is I'm going to do 180 minus 35 minus 15, and that gives me 130. So I know that this angle right here is 130 degrees. I'm not sure where to start, but I at least know how to total up the angles of my triangles. The next step that I'm going to do is I now have an angle and a side that's opposite of it. So I'm going to use my law of sine. So I'm going to say sine of 130 degrees over 20 is equal to, now here's what I want to do. I want to find side A. There's a reason they probably called it side A. So I'm going to say sine of 35 degrees over A. I'm going to solve this out using my law of sines. So I would cross multiply. This gives me 20 sine of 35 degrees equal to A sine of 130 degrees. Solve for A, so I'm going to divide by sine of 130 degrees. So A would be equal to, using your calculator, you should get about 14.98. Now the last thing I need to do is, I now have 14.98, and the reason I want to do that is because I have to find the height. So in order to find the height, now that I have kind of more information about what's going on with my triangle here, I'm going to use what I know about sine. Sine of 15 degrees from this angle is equal to opposite over hypotenuse.